Hello everyone, so this is my presentation about our paper, an XGBoost model for age prediction from COVID-19 blood tests. My name is Nunung Nurul Komariah, I'm from Bina Nusantara University. So the introductions, many studies found that COVID-19 disease attacks differently to people of some age groups. Predicting age from blood chemistry is a common method in health science. Nevertheless, aging is a very complex process. Health scientists study this topic for the reasons that the aging process in the human body is not a straightforward information. Some related work in this study include many studies found that people aged 50 years or older were having higher risk of mortality when exposed to COVID-19 disease, as mentioned in the reference number 1. Based on a study conducted by Bauer et al. In reference number 6, they found that some age groups shows higher risk when compared to the other groups. Silveira in reference number 13 shows that the addition of patients' age as a feature with their blood count result in predicting COVID-19 can achieve a model's accuracy of 80% with XGBoost. So our contributions in this paper consist of: first, we're reporting findings of age-based study analysis from blood test data. And the second contributions is make the pre-trained machine learning model resulted from our experiment publicly available. Research methodology. Datasets from Pasar Minggu Hospital Jakarta have been collected. We have 1,000 inpatient data with confirmed COVID-19 case. We also have additional data, 1,000 inpatients with pneumonia cases and 1,000 inpatients with other disease. This is the exploratory data analysis. First, the histogram of age in each class. We can see in the COVID class, there are a lot of people who are aged in between 30 up to 35, up to 65, with the biggest point is 60. While in the pneumonia and other cases, the distribution's quite the same. And then when we have a look on the proportion of class in each age group, we can see that people under 16, the proportion is quite similar, with pneumonia more than COVID and other, while people between 17 and 33, we can see that so many COVID patients when compared to pneumonia and other disease. Between 34 and 45, the distribution, the proportion of the patient also the same. COVID still dominated the dataset. Between 46 and 58, also the same. COVID patients are more than pneumonia and other. Between 59 and 71, it's similar like other groups. COVID-19 disease is the major disease in this group. And above 72, we can see the proportion is quite similar. The machine learning techniques that we use, that we implement in this study are decision tree, XGBoost, SVM, multi-layer perceptron, and kernel-ridge regressions. Result and discussions. So based on our experiment, we can see that the clustering, the best clustering that we can have for our dataset is 6K. So we implement K-means with the result of 6 clusters. And this is the regression result from all classes, we have XGBoost decision tree, SVR, MLP, kernel-rich regressions. The R-squared score, we compare the R-squared score, RMSE, and normalized RMSE. We can see here that XGBoost leading with 82%, with the RMSE is quite low, it's only 8.23, and normalized RMSE almost 0. And then when we break it down again, we can see from each class, we can see that COVID, when compared to pneumonia and other, COVID has the highest score. When we see the R-squared score of XGBoost in COVID-19 datasets, we can have 87%. While the RMSE is only 6.15 and normalized RMSE 0.07. And when we plot the result of the predicted age value, we can have a very nice data, very nice output, and then we compare it with the actual age value, we can have something like this, which is the predicted label with the predicted age when compared to the actual age is quite similar. They lies in the center of this diagonal. When compared to the decision tree, we can see it's quite spread out. Okay, so the conclusion and future work. In this paper, we have explained our research on predicting age based on blood tests from COVID-19 patients. We also compared the result with 2 other classes, pneumonia and other. The experiment shows that XGBoost and decision tree yielded a satisfactory result for age prediction. The prediction made from COVID-19 blood test data also shows the best performance when compared to the other 2 classes. In the future, we want to expand the research for COVID-19 mortality prediction from blood test data with correctly predicted patients' age. We want to examine whether this additional information can improve the prediction when compared to the blood test data alone. Thank you very much for listening to my presentation.